So today we will be discussing one more problem in connection with the support reaction. So in the figure you can see two beams AB and CD, in which AB and CD are hanging beam, and we got support of beam AB at point E and the support of beam CD at point D and C. So while analyzing this kind of problem, we have to analyze the top beam first and we have to find the reaction, and that reaction will be treated as a load for the second beam. Okay. For that, we will be analyzing the first beam. First of all, we will check what are the loads available. We have a 20 kilonewton, that's a point load, which is vertical position. And we have 40 kilonewton, that's a point load, but it is an inclined position. So we will be resolving these force into two components, 40 sine 45 and 40 cos 45. We will be resolving into two components, 40 sine 45 and 40 cos 45. And we have one more inclined force on the beam CD. It is 20 kilonewton, which is inclined position. So we'll be again resolving into two components, 20 sine 60 and 20 cos 60. And this is a moment, two equal and opposite force separated by distance. It's a couple. So it is effect is given by force into distance, that's equal to 10 into distance is 1 meter, that is 10 into 1, and it is creating a anti-clockwise couple. So we can replace this with a couple or moment having anti-clockwise direction, and its magnitude is given by 10 kilonewton meter. So we'll be redrawing our given question. The beam AB, on the left side it was a hinged support, so it will produce both horizontal and vertical reactions. So we have marked the direction. So normally we will be marking the reaction, horizontal reaction direction in the right word, but in this we have marked it just towards left, because from the figure itself we know that the 40 kilonewton got both horizontal and vertical components. The horizontal component is towards right, so the reaction developed will be towards left. That's why they have marked the reaction component as towards left. If we mark the reaction direction towards right, we will get the value as negative. So no problem in marking this direction as towards right or left. So by using common sense, we can understand that the reaction will be towards left. Let's say they have marked the reaction of HA. That is, so in some book it is written as RAH or HA, horizontal reaction at point A towards left, and we have vertical reaction as it is a hinged support, and at point D there we are providing a roll-up support, so we will have only vertical reaction, so we will be marking it as RE. That RE is act as a load for the second beam. So we will analyze in the next step, and we will be marking the load 20 and 40 kilonewton. First of all, we will be taking the moment with respect to point A. So we will be while taking the moment, first force is 20 kilonewton acting at a distance of 20. Actually, the distance is marked here in the first figure, 1 plus 1 plus 1 plus. So total 20 is acting at a distance 3 meters. So we will be writing 20 into 3. It's a clockwise direction. Next one, 40 cos 45 and 40 sin 45. We got two components, 40 cos 45 horizontal, 40 sin 45 vertical. So we will be getting 40 sin 45, distance equal to 4 meters. 4 into 40 sin 45. And the last force is reaction at the point D, RE into distance equal to 3 meters, RE into 3. So from this we will get the value of RE as 57.1. And when by equating the horizontal and vertical force, we can find the reaction force at point A. Horizontal reaction is 28.28 kilonewton. And by equating the vertical force, what are the vertical force? VA is vertical, RE is vertical, 20 is vertical, 40 sin 45 is vertical. So by equating all these, we will get the value of VA also. So we got two values for reaction at point A, horizontal reaction and vertical reaction. So we can calculate the net resultant reaction at point A. Okay. And next we will be analyzing the beam CDF. Okay. In CDF, we will have a load RE at a distance 3 meters from the point A. From point C, it is at a distance of 2 meters. So this will be at a distance of 2 meters. Okay, and we will be taking the moment at the point C. We will be taking the moment at the point C. What are the forces? It is, we got RE and the moment. So we will be writing RE into distance. Distance is 2 meters. So we will be writing RE into 2. Next force, reaction at the point D, RD. As it is a roller support, we will have only vertical reaction. So RD into the distance is 3 meters. So we will be writing RD into 3. And we will have one more force, 20 kilonewton. You will have vertical and horizontal components. Vertical component is 20 sine 60. So 20 sine 60 into distance is 1 meter. And then we will have one moment. It is in the anti-clockwise direction. As it is anti-clockwise direction, we will be subtracting or adding negative sign to the moment, minus 10 equal to 0. By solving this equation, you will get the value of RD as 40.91 kilonewton. As we know the value of RE from this solution. From this solution, we know the value of RE as 57.51. RE is equal to 57.51 kilonewton. We will be substituting that value here. Not 51, not 71. Okay. So we will get the value of RD. And by equating the horizontal and vertical reaction, we will get the value of RC horizontal and RC vertical. RC horizontal is only one horizontal force is 20 cos 60. As it is towards left, the reaction will be towards right. So we will be writing the direction of HC as 10 kilonewton and value is 10 kilonewton. By getting the vertical force we got a reaction at point C, reaction at point D, and RE are the vertical force. So and the 20 sine 20, that's the vertical force. We will get the vertical force as a 34.12 kilonewton. So this is how we will be solving a beam mount over another beam. So reaction of the top beam will be treated as the load for the second beam.